on the and also, are you sharing some slides or you'll just speak impromptu?
I'll actually just speak. So Firoz, since he said he already has some introduction slides, so he can
So,
just give a brief
Vikas, can you
introduction.
please share, turn on your camera to see if it is working?
Okay, sure.
Okay, perfect. So, Atif, I'll begin the webinar, invite people in.
Yes, please. We'll still anyway wait. So
So we're starting the webinar and we've begun the recording. Welcome everyone. We will just begin in about 5 minutes. We're waiting for people to come in. We are live streaming this session on the CCAMP Facebook and YouTube pages, as well as the Blisk YouTube channel. So for all of you joining online, just please wait for about 5-10 minutes or 5 minutes, our webinar will begin. Okay, so I think I shall begin. We have several people watching on the YouTube channel from the Blisk YouTube channel, and we also have a fair number here. We've had over 200 registrations for this webinar, and for anyone who has joined as an attendee, for any questions, please just put them into the Q&A box. There is a Q&A icon that you will see. Please put your questions in the Q&A box. In case you want to ask your question on air towards the end, you will find a raise hand icon. Please tap on the raise hand icon and we will unmute you so you can raise your hand. Also, for those of you watching on the CCAMP and Blisk Facebook and YouTube channels, please put your questions there in the comments and we will come back to you. We will relay those questions into the webinar for our expert panel to answer. So with that, I will hand it over to Tebarshini, who is the communications manager for CCAMP, and she will introduce our people and the session. Over to you.
Hi, everybody. Good morning and welcome to this third edition of the CCAM Technology and Innovations webinar series, CTIS. CTIS is an attempt to take you backstage at CCAM to meet, greet, and interact with the people behind our many programs and facilities. Most of you are aware that CCAMP, or Center for Cellular and Molecular Platforms, is one of India's most exciting bioinnovation hubs, where we promote cutting-edge research and innovation in the life sciences. We are also a part of the Bangalore Life Sciences Cluster, or BLISC. So today we will discuss all things micro, all things big and small in the micron-sized world that exists imperceptibly in a universe parallel to ours. Imperceptible until you bring them into focus and manipulate them through cutting-edge science to develop innovative new technologies that make our lives easier. And one such cutting-edge science is the science of microfluidics. And today we bring you a closer look at CCAM's National Biopharma Mission supported National Rapid Prototyping Facility, microfabrication facility called MUFAB, which is a first of its kind facility in India that aims to help academics, startups, and industry develop and commercialize novel innovations, especially in the diagnostics arena. Now, I pass on the mic to my colleagues, Dr. Atif Alam from CCAM Technology Platforms Program, Dr. Firoz Mustafa and Subhash KM from MUFAB to tell you more about MUFAB. Over to you, Atif.
Thank you, Debashini. Good morning, all. Hope you have a good time. Can you see my screen? Is my screen visible?
Yes, it is.
Is the presentation slide?
Now it's not. It was visible.
Okay. So while I set up the uh, presentation, just wanted to quickly tell about CCAMP. So I'll take basically a few minutes just to walk through what we do at CCAMP in order to set the tone for the discussion that will be led by Feroz and Subhash. The idea being we will discuss more about your problems in medtech and microfluidics. We will want to keep it interactive, discuss ideas which you have, or perhaps problems that you are encountering, and then take them as much as possible here. Otherwise, things which are confidential, we will keep them for a later stage when we follow up with you. So what I will do is quickly give a brief about CCAMP. My name is Atif and I work for CCAMP's business office and look after the technology platform services vertical. Uh, a quick introduction to what CCAMP and where we are. We are part of the Bangalore Life Science Cluster, which has three institutions, namely the National Center for Biological Sciences, NCBS, India's premier biology research organization, which is very well known globally as the fundamental life science research organization. It's about 25 years old organization, part of the Tata Institute of Fundamental Research life science program. Uh, INSTEM, which is the only federally funded stem cell institute in India, funded by DBT, started in 2010, is doing some novel and cutting edge research uh, in the stem cell and related areas. On the other hand, CCAMP is a unique organization, perhaps the only of its kind, started again back in 2010 with a very unique mandate of offering services and enabling the researchers from every sector of every sector, that is industry or academics, to enable their research and bringing innovations from life science to market. So essentially we handle our affairs in two large verticals. One is the technology platforms, where we develop and offer high-end technologies and provide training on these technologies. And then we also have a very large portfolio of entrepreneurship programs, right from funding reaching out to potential innovators, going to the early stage of funding, connecting them with mentorship and helping them take it to the next level where larger fundings are available and seeing them all the way through market. So this is where CCAMP can help in case you are in the startup arena or you are wanting to start your own venture. Uh, that is a very long discussion for some other time. Today, we are moving towards a closer discussion on medtech and small devices. Just to set the tone, here is the large portfolio of services that CCAMP offers through the life science cluster. So all the facilities that are listed here on this slide and the subsequent slides are shared in the campus, and we have anybody from outside of the campus has access to them in a service mode. Just to quickly run through them, there are massive portfolio of next-gen genomics and mass spectrometry services. Then we have flow cytometry facility. We have perhaps the unmatched, unparalleled imaging facilities spanning all the imaging segments: AFM, confocal and super resolution microscopy, electron microscopy, uh, X-ray 3D microtomography, and so on and so forth. You can see the representative images, but in case you are interested, we will set up a separate time to go over each one of them in depth. Again, on molecular characterization, we have NMR, X-ray, and cryo-electron microscopy facility. When you need animal models for research, we have the only uh, mouse genome engineering facility and the Drosophila transgenesis facility in the country. These are federally funded by the DBT to support researchers both in academia and industry if they wish to use these as model systems in their research. A bunch of core equipment which are day-to-day use, but still, if they're not available at your institution, feel free to reach out and we'll be happy to offer them to you. There's something which we will be discussing today in depth, that is the microfluidics, microfabrication, and rapid prototyping. So I'll not spend any minute here. I'll go to when Dr. Firoz takes over. All this effort has led to hundreds of publications which are either co-authored or have been possible when there was a technology used from the cluster facilities. They're listed on one of our web pages for you to have a look in case you want to see what kind of work has been done or what is possible. This serves as a repository to find relevant publications which have come through these services. Feel free to have a look at it. And an aspect which is very, very important that we feel is the aspect of training researchers on these high value equipment, which may or may not be available in your institution. But while we have them, we want to train people so that they can go back and use them more efficiently. And then also it helps us, our colleagues, to learn it in return what the problems and challenges people are facing and how can we help as well as improve our own resources and uh, our own knowledge. So I'll stop here and basically hand over to Dr. Firoz Mustafa, who I'll introduce in a bit, and he'll talk more about the micro devices or the topic at hand today. But before that, I wanted to do a quick speed check, a small poll, just to know the kind of audience we have today with us. So there'll be a poll that will show up on your screen in a while. Uh, my colleague Chandrakant will display it. There are basically three very simple questions. Yes, please. Thank you. Please look up for your screens on your screens for these very simple polls. We would not want to know who you are, where do you work, and there's another last question as to what specifically are you looking at to learn in today's webinar. So I'll give a few minutes for you to um, fill it up. Yeah, we can see. Good. We have nice, nice. Chandrakant, could you display the third question if
Yes.
possible, so that people know that there is
All
a
three
third question?
questions are there. They just need to scroll down to just
Oh,
get.
okay. Acha, acha, acha. Okay, oh, right. Okay. Wow. Very well.
We have 81% voting so far. So I request the few people who haven't voted yet to vote. 81% is better than the usual voter turnout in the world, but yeah. I think we've had our the people who voted have voted.
Very nice.
Okay. So
Am I okay?
no?
Sure. So, can we just move it, and can it still be on for a few minutes? Yeah. Okay. Sure.
I can
Perfect. Oh, wow.
relaunch it if you want. I can relaunch the poll and keep it there.
No,
While
that's okay. That's okay. I think we have got about 80%, you said.
yeah, 80% voted.
So, very gladly, we have about equal representation of uh, both the genders, male and female. And then we have close to 57% academic researchers, and 78% people are interested in design. Thank you all for sharing your choices in the poll. This helps us definitely to set the tone for the next part of which the crucial part of the webinar, and that is to dive to the microfluidics aspect. Here I would like to introduce my colleague, Dr. Firoz Mustafa. Firoz, as we call him, works as the facility director for the NBM supported MedTech Rapid Prototyping MUFAB facility at CCAMP. This is a unique facility, as my colleague Debashini told earlier, and we will hear more about it from Firoz, who also hears, by the way, multiple hats. One is as his role as a facility in charge for microfluidics and microfabrication facility, and also he is the facility in charge for the confocal and super resolution imaging facility. Uh, so with this, I'll hand over to Firoz. Welcome, Firoz, and we would like to hear from what you have to say, as well as, more importantly, hear from our participants as to what they are working on. So over to you, Firoz, and I'll leave it with this slide.
Thanks, Arthur. Hi, I hope everyone can hear me. So I'm Firoz. I'm the facility in charge for the microfluidics and microfabrication. As I see, most of you come from the academic background, and there is also a significant portion from the startups. So let me give you a brief glimpse into what we are aiming to do here. So the microfluidics facility at the Bangalore Life Science Cluster was set up as a support facility for the campus to start with access to external users. So we had set up a small photolithography facility with a mask aligner for SU8 fabrication, along with PDMS fabrication capability, so that people using PDMS microfluidic devices can make it here. And then we saw the requirement for plastics fabrication and design from external users, and we have gotten funded for this NBM MedTech facility, which we have set up. And the idea here is that we can take you from design all the way till pilot scale in a single facility for plastic devices. So we tried to incorporate as much as we could in our under our funding, and we are trying to look for options to expand and include more technology capabilities as requirements pop up. So the first and most important, of course, is we have a design studio where you can walk in with your idea. It can be on a PowerPoint slide. It can be even just something that you have in your head, and we help you convert it into a proper design which can be fabricated. We consult for the design challenges in which we can make sure that the designs that you come up with will be something that will be convertible to a device, because there are always specific considerations you need to take into account when you are going for PDMS devices, injection molding, CNC milling, etc. And so once you have the design in hand, we have the possibility of, well, we already had the PDMS device facility, so if you want, you can get that made, or we can go for plastics through multiple routes. We have a 3D printer as well as laser cutter for very crude, fast making of devices. We have also procured a 3D CNC micro mill for fabricating devices at up to 25 micron resolution. So the 25 micron I am specifying here is the end mill. So you can make 25 micron channels using that as a minimum size. Apart from this, for the next level of prototyping, and we have vacuum casting setup. And if you are going to pilot scale, we are setting up the injection molding setup in a class 10,000 clean room facility, also with packaging. And we are getting it ISO 13485 certified, so that decreases your time to market. So this is, and so now all of this makes no sense if you don't have a testing capabilities. So we have surface profilometers, both stylus and the optical kinds, as well as a bit of microscopic testing capabilities with all three kinds of pumping systems and National Instruments LabVIEW based DAC system, and a fast camera for acquiring up to about 50 kilohertz. So this is what we have set up. And maybe if anyone has anything specific that you want me to go deeper into, can we have a show of hands so that we can address questions one by one? No one has anything to say, ask?
If you have a question which you want to speak out online, please raise your hand and we will unmute you.
Okay, 3D printing. So, okay, 3D printing, basically, most of you would have seen, in the recent years at least something or the other which has been 3D printed. This works, it's a additive manufacturing technique, which means that you add layers to it to make. And the most common 3D printers work by, they are called FDM 3D printers. They work by taking a filament of plastic, melting it through a nozzle, and then layering it little by little in the design that you want. This is what you would have most commonly come across. The typical resolutions here are about, slightly below a millimeter. Even though most of these systems will claim resolutions of 100 microns and stuff, that is only in the Z direction, and in the XY direction, the 3D printing is much worse. And it is not ideal for most of the microfluidics based applications. What it is great for is making a good model very fast. You can even make a microfluidic device out of 3D printing. We have done it. The issue that pops up is that the walls are not smooth. You will have striations between different layers. So this is not the optimal 3D printer. So if you want the best 3D printing possible for microfluidics, you need to go for SLA 3D printing or desk jet printing, 3D printing, inkjet 3D printing. These are both more expensive, both in the consumables and in the case of the inkjets, the machine itself. And they can go down to about 30 to 50 microns in resolution, in actual resolution. And they are the ones that you would want to use if you are actually going for microfluidics, 3D printing for microfluidics. So as about other details, typically the first thing in 3D printing, you make the 3D design either in AutoCAD or preferably in SolidWorks. And once you have the design in hand, you can improve the, once you have the design in hand, you can import it into the 3D printer, into its own code, and that will 3D print for you. The things that you need to consider specifically in FDM 3D printing are that vibration. It should not be on a surface that vibrates. That will cause errors in the printing. B, the temperature should be controlled. While the machine itself doesn't care, if you don't control the temperature, and if the temperature varies significantly while you are printing something, it can have something called plane shift, where half of your device is printed in one plane and half the other has a slight shift to it. And you can even have more than one plane shift in one single printer. So this is not a very ideal thing to have without of course, you also would preferably have humidity control. So all this makes 3D printing not ideal for microfluidics. Of course, if you have an inkjet printer, they are very expensive. In fact, the running cost of the inkjet printer come close to photolithography. So we don't prefer that. We have a normal 3D printer in-house because when you are making prototypes, you want to be quickly able to make adapters and such. So we use it for that. But I strongly do not suggest 3D printing for microfluidic devices. There are better technologies out there, like the CNC micromilling. So CNC micromilling is our technology of choice for making one-off designs quickly. So again, the design can be made either in a um, SolidWorks or AutoCAD. And the advantage of this is that you can, this is a subtractive fabrication, where in 3D printing, you add layers to make the 3D surface. In CNC micromilling, you take a solid block and then you cut into it. So the difference, so CNC here stands for computer numeric control. Basically, when you give the CNC machine a design, convert it into its own programming language, and it takes the design and it can automatically run it. So it doesn't have to be manually run by a person. I mean, there has to be someone to load it and press the button. But the shape of it is not determined by a person. It is determined by the computer. And that makes it very, very precise in the micron scale. With a person, you cannot go down to that level easily. I mean, of course, there are always people who have worked for 20, 30 years in the CNC milling field who probably can do it. I will not say anything about it. But this makes it very easy to make microfluidic devices repeatably in a very precise manner. And the machine we have is a micro CNC model, which is optimized for making very precise micron scale resolution cuts. And we can go down to about 25 micron elements, which means the cutting tool is 25 microns in diameter, which is what determines the minimum resolution we can go to in a. So just so that we are clear, when I say resolution, I mean the size of the channels we can make and the smallest features we can make. When typically in most CNC work, they say resolution, they mean how precisely you can move the tip. And there they quote about a 10 micron figure for the very large CNC mills some of you might have seen in the machining workshops. So that is not the resolution I am quoting. That resolution for this machine is about a micron. What I would call the precision. The resolution here I am talking about is the feature set that you can make. So basically what you do is you make the design, you convert it into the programming language of the machine, and you load your plastic substrate onto the machine. And after centering the mill head, you just press on and it will make a design for you. So that's CNC micromilling for microfluidic devices. So this is the technology that most companies use when they want to make initial prototype or proof of concept devices, because you can make 1, 2, 10 devices, but of course once you go past a certain number, you want to have something which will make the devices fast. And CNC micromilling, it's great if you want to keep making minor modifications device after device to see what works. It is not great if you want to make 1,000 copies of the same thing. If you want to do that, then it's better to do the vacuum casting, or even better, the injection molding. Could I give you a microfluid? Do you mean an example, or how? I mean, whether we can make and give it to you? Exactly. Most microfluidic devices, anything you see in papers talking about PDMS microfluidic device, we can make the same design in CNC milling. If I would want to give a rough this thing, okay. So in CCAMP itself, we have developed and patented a microfluidic flow analyzer, which was initially developed using PDMS-based microfabrication. But now we have also used plastic molding to make, plastic CNC milling to make those. And as of the latest point, we are trying to switch to glass for that. Okay.
Because I have a question here. So you mentioned glass. So can you do
yes.
CNC milling on glass?
No, we can't. So
Okay.
glass is very expensive to work with because it can shatter. So, I mean, the only thing that you can do CNC on glass is if you want to drill a hole straight through it. If you are going sideways in glass, it shatters. So for designing things in glass, we have to use something much more complicated like excimer lasers and then doing etching with chemical processes. We are in the process of trying to get some funding for it, but as of the moment, we haven't yet secured it. And these are, since they are very also quite expensive technologies, we are trying to figure out if we have enough requirement for it in the field, even if we set it up.
So a typical example for a plastic microfluidic device would be what? I mean, this is just a question while we are waiting from the audience.
Yeah.
But
No.
if I were an uninitiated, what would be a typical plastic microfluidic device that I would most likely be encountering?
Okay, so very okay. Roughly speaking, what would you be encountering? Right now, with in the market, you wouldn't really see too many microfluidic devices floating around in the customer space. So these are more often used in the lab space or in the hospital space for diagnostic devices. So, I mean, paper microfluidics, everyone can give the example. There is the, what do you say, the glucose testing system. For plastic microfluidics, for example, Achira Labs, Bangalore has developed a few diagnostic devices which run on plastic. Apart from that, Big Tech Labs has also developed diagnostic devices using plastic. Other than that, a lot of lab-on-chip devices can be done in plastic as well as in PDMS. So effectively speaking, plastic is a great substitute for PDMS when you go from the lab scale to the commercial scale. PDMS is what most labs use to develop microfluidic, what do you say, test. But once you have the device, it's not easy to scale up a PDMS device. So at that point, you go to a plastic device for scale up. Of course, if you are a company which is interested in going to the market fast, it doesn't make sense to waste your time in PDMS, but just go straight to plastic.
There's some noise.
Okay.
I don't know
That's
whose side.
There's a little bit of construction happening here, so I'm very sorry, but
it's
I was hoping
okay.
the mic would not be picking it up, but
Okay, sure. I think
okay.
it's time to also introduce the other speaker who's there with us, Subhash. Hi, Subhash.
Hello, Atif.
Hi. Good morning, Subhash. I just wanted to give a quick introduction about Subhash. So Subhash works with the Rapid Prototyping Facility as a project engineer. Subhash is a bachelor's in telecommunications engineering and a master's in electronics and communications engineering. Before joining us, he was working at IASC Center for Nanoscience and Engineering. Subhash, over to you. And if you would like to say a few words, or I don't know if you have a slide or something.
Sure, Atif. Thank you. Thank you very much for the introduction. So I would like to speak on few things. So if you see the microfluidic regime, like till 1 micron to 1 mm, right? So the way of manufacturing it, you have different technologies like CNC, micromilling, and photolithography. So the thing here is, so as the resolution comes down smaller and smaller, so you need to have a different technology to manufacture it. Like, so CNC micromilling can do up to like uh, 50 microns till 1 mm in that scale range. So if you want something lesser than 20 micron or 10 micron, you need to. So right now the current technology, what we have, you need to go to like photolithography and all those things, microfabrication. So so the catch here is, so there are different technologies with respect to sizes what we work on. Suppose in your design, okay, so if you have something a bigger size channel, like you have 500 micron, and in the same design you have something uh, like less than 10 micron. So here you need to think upon and choose the right technology to manufacture it. So here, this is where we, as our center and our facility, come into picture. Like, so we can provide you design support as well as manufacturing support, and to choose cleverly what technology you need to uh, choose to manufacture these devices. Okay, so this is what our facility is there to support you with in microfluidics field. So here my my work focuses on providing design support to you, and photolithography support, and PDMS fabrication support. Suppose say you have all your devices, you have like something lesser than 25 microns. So there you need to actually go for something, uh, the process called photolithography. So basically this is, uh, you need to create a design. Okay, so you need to transfer that design onto a mask. From the photo mask, you need to transfer that design onto your substrate by coating a photosensitive material. So in this case, it would be like SU8 devices. Okay, so it's a big process, and it's an expensive process compared to all the technologies like what we have at the center, like CNC micromilling or injection molding, vacuum casting, etc. So so here where the cost come into picture of manufacturing it. So as your channels get smaller and smaller, we need to uh, think what technology to choose and manufacture. So here where we actually provide you proof of concept support and prototype support, and from right from your idea till pilot scale manufacturing. So, something you need to think and choose cleverly what technology to manufacture based on the cost point and your what is the actual thing your project requires. So So these are the things you need to keep in your mind while designing the device till the pilot scale manufacturing.
I think thank you, Subhash. There are a couple of questions, and I think the first one to the regulatory
Yeah,
framework for microfluidics. As Firoz, would you like to answer?
yeah. So for microfluidic chips and lab-on chips in India, uh, right now, as of the moment, there is no specific regulatory framework which kicks in. But when you design it, it would be good to go to FDA 501K for the approval. And usually, any FDA approved chips are approved without any issues in India. So that would be my suggestion to design taking into account FDA 501K. And of course, your devices need to be made in ISO 13485. Sorry. So this is for diagnostic chips. If you are talking about microfluidic chips or lab-on chips, when you say microfluidic chips, it encompasses a variety of things. If it's something which is going to be used in a research lab, there is no regulatory framework. As long as it fits the requirement, that's fine. Lab on chip, again, typically it is used to mean one thing. I'm not sure if that's what you mean. Lab on a chip is for making complex biochemical reactions on a chip. It can be what do you say, organ on a chip, or it can be even more complex. So if that is the thing, again, there is no regulatory framework except for any IBSC approvals you would need for using the chip. But if you are talking about multiplexing of diagnostic, what do you say, tests, that would again, you will have to go through the, what do you say, ICMR and other approval agencies. In the US, it will be FDA 501K. And my suggestion to anyone has always been to go for the FDA 501K because it makes it easier to get it certified elsewhere.
And Atif, we have a question from Sudha. So is photolithography also available for prototyping?
Yes,
The
please go ahead.
simple answer is yes.
Yes.
So everything we have is available for access. The more complex answer is photolithography. We wouldn't suggest for prototyping because making the initial mold is expensive unless you have a specific design which you will be replicating in your lab. So yes, you can. I mean, we will do it for you. But you have to work out if that will work out cheaper for you or if you would prefer using the plastic.
Thank you.
Minute.
Chandrakant or Debashini, are there any questions from the other feeds which we are not able to see here?
Is CCAMP microfluidic facility fully functional right now? Okay, CCAMP microfluidic facility is not fully functional right now. Sorry, fully functional right now.
1 second.
Okay.
Nothing on YouTube, CCamp YouTube so far.
Okay, let me go back to the question. So the thing is, it is not completely functional right now. It will be fully functional by around August. What is fully functional is the photolithography and PDMS facility, as well as the design facility. The prototyping with 3D printing and laser cutting is also immediately accessible right now. The CNC milling, the machine has been shipped, so we expect it to be functional latest by April. The injection molding and testing will be functional by somewhere between June and August.
I had a question here, or rather, so we're setting up a clean room. Is it also going to cater to the packaging requirements, or what's the plan? Maybe it will help
Yes.
for the pilot scale
Yes.
part of the.
Yes. We are setting up the pilot scale and packaging in the clean room. So the clean room itself will be a class 10,000, and it will have the injection molding setup. Apart from that, we are having a nano dispensing system for packaging. So if you require those, it will be accessible. So this will be in a class 1000 hood. And so there's also one more about device modeling. Yes, we do provide device modeling or flow simulation for the device before finalizing the design. So we currently have a full SolidWorks studio, including the flow simulation. We are also in the process of procuring COMSOL for use for flow simulation.
While we again wait for a few more questions, sorry, there's again construction here, so my apologies. I had a question. So, are we planning to conduct some trainings on people for experiencing all this thing in a more handy fashion? Maybe
Sorry, I should have
permitting
covered
next
it.
year.
Yeah. So okay. Right now we are even now next year, January, we are conducting a design workshop. And so the thing is, we want to conduct workshops which are hands-on. So we will be choosing just 5 people, and we will be giving them VPN access to our SolidWorks design studio here, so that they can access the computers and run it from their own machines. So this, we are in the talks with the people who run SolidWorks to set it up. So please look out for it sometime around the 15th of January. We will have a design workshop. After that, once the COVID lifts, we will have hands-on workshops. We plan to have at least 2 workshops a year. Most likely, we will conduct more. And we will split the workshops into specific, focused on individual things, so that people who are interested in those specific things can apply for those. So for example, we would have a rapid prototyping workshop with this CNC milling. Design CNC milling. You see how it looks like, what are the difficulties, etc. And we have had, and we will continue having PDMS device fabrication workshops, where you make the devices, quickly check it, and see how it works. And also we give you an overview of how to design stuff. And once the testing platforms are online, we will have workshops on those as well. So we plan to have smaller workshops covering individual focused things rather than one covering the whole facility, as I think that would waste less time for everyone concerned.
Thank you. There is a question from Arun. However, if it'll be good if you can speak up, Arun. Chandrakant or Debashini, could you unmute Arun to speak, to be able to put?
Arun, you may unmute yourself now.
Yeah, good morning to one and all. Can you hear
Hi,
me?
Arun, we can't hear you. You are very, very
Hello, can you hear me?
uh, barely.
It's very quiet. Can you
Mm,
speak a little louder, Arun?
Now can you hear me now?
yes.
Now it's better. Yeah.
Yeah, so like I'm an aeronautical or aerospace engineer. So like, but I have more interest in like in fluids and in computationals. So I like if I want to work over in this in microfluidics, and then so how I can work or how I can join and I can do research in this.
Okay. So, as an aeronautics engineer, I assume you have already have a lot of experience with fluid flow simulations and stuff.
Yes.
There, I can already see that there, a lot of people will require that expertise. Arun, are you a PhD student or a master's, or what level are you at?
Yeah, like I already completed my master's, and after that, I have 5 years
Okay.
experience in research and academic, and
Okay.
I'm looking for my PhD also. That's what I'm saying.
Okay.
Yeah.
So see, I would, so you can straight away apply for PhD programs in bioengineering, especially in institutes which hire, which do research in the interface. Uh,
Okay.
so, for example, Raman Research Institute has faculty who work on microfluidics. ISC have faculty which work on microfluidics. NCBS has faculty work on microfluidics. In all these three institutes, I know that they do hire people from other streams as well, especially the engineering streams, for PhD students as PhD students. In NCBS, of course, your PhD will come with a biology stamp, but you will have no issues switching. Don't worry about that. What you would need to do is play to your strength, which is that you have experience with simulations as well as I'm assuming a bit of fabrication as well.
Yes, I have.
Yeah. So use that, and you can use that to apply. Um, so there are quite a few Indian institutes which have this kind of. A lot of the IITs again will hire you, no questions asked, as a PhD student to work on microfluidics. IIT Madras has a good microfluidics program. IIT Bombay has a good microfluidics program. Delhi again has good. Um, uh, I mean, these are just programs where I am personally acquainted with, but there are quite a few options.
So my question is that like so this the study will be like to making a device or like it will be biological part also concept also will come in.
So, okay, so it's like this. So microfluidics by design came from a bit of the silicon fabrication technology. That's where the first, basically microfluidics as a field started because Intel gifted all their old equipment to universities when they were like writing them off. Now, so it requires a lot of different expertise. It requires you to know a bit of chemistry, a bit of mechanical fabrication, a bit of design, simulation, as well as if to actually apply it to a biological problem, you need to understand the biology as well, biochemistry. So usually, this when someone is doing microfluidic research, it is a group effort with each person adding a specific viewpoint to the thing. Uh, so, so that's how it comes. It's never one person who can do everything. So, for example, I come from sort of the interface. I have a degree in, I have a BTech in biotechnology followed by a PhD in biology. And what I do is while I don't have the complete expertise of the biologists who are biochemists or someone like that, I can speak the language as well as I can speak the language of fabrication and simulation. So, and with them develop things. So that's the kind of sort of focus that you need to be looking at.
Thanks for that. Introductions and also my question.
So I think we are closing on to the time we had allocated for the webinar. If there are questions, could you quickly put them in the chat box, or I think Debashini will be able to tell about how we will do a follow-up in case there are questions people want to take offline. We do understand that there would be questions that you may not want to ask in a public forum due to confidentiality reasons. So in such cases, feel free to reach out to us offline, and we'll be able to take the discussion. Should there be a need for a non-disclosure agreement signed, we will be happy to do that. So thank you from my side, and it's over to
Debarshini?
Yeah, so I think to move on to what Atif just said. So all of you will receive an acknowledgement email from our end, giving you the links, email IDs of Firoz, Subhash, and Atif as well, and so that you can get in touch with us directly for any questions or queries that Atif just mentioned. More than that, I think we are very close on the ending time. So if there are no more questions, then we will close this session today. It was a thank you, Firoz, thank you, Subhash, and thank you, Atif, for giving us such a in-depth view of the rapid prototyping facility. I hope it answered all of your questions. And so with that, I think, Chandrakant, I think maybe we can close today's session.
Yes. We'll close the session. The webinar is also recorded onto YouTube, so you guys can check it out whenever you want or share it with your friends as well. Thank you so much and have a good day, everyone. Bye-bye.